Section 7.4, confidence intervals for variances and standard deviations. Because we're talking about trying to find the confidence intervals for these two, we're going to definitely be using a different type of distribution. Here are some examples of why we would want to know the confidence intervals for variances and standard deviations. Take a few moments to read through the first two bullets. You'll notice with both situations, we want to make sure that our values that we're getting fall within a certain range. Otherwise, it won't work. For example, with the pipes, it won't fit into where it needs to go. Or with the medicine, you'd be under-medicated or over-medicated. Two very highly bad situations could happen there. That way, we need to know those intervals and to know how confident you are that you have the right values. With this being said, we're now going to be using what's called the chi-squared distribution. The chi-square variable is similar to the t variable in that its distribution is of a family of curves based on the number of degrees of freedom. Recall, degrees of freedom is 1 minus your sample size. The symbol for chi-squared, it looks kind of like an X, but it's pronounced chi. The chi-square variable cannot be negative and the distributions are skewed to the right. At about 100 degrees of freedom, the chi-square distribution becomes somewhat symmetric. The area under each chi-square distribution is equal to 1, or 100%. You will find the chi-square distribution in Table G. When you're looking up your values, you're actually going to be looking up two values. You're going to be looking up chi-squared right and chi-squared left. Here we want to find 0.95 and 0.05 for our alpha and a 24 degree of freedom. Looking over for the 24, we have the left value is 13.848, and then the right value is 36.415. What this is saying is that your left value, our area is 0.05. There is our chi squared for the left, and then your right value, our area again is 0.05, and there is that chi squared. The formula for the confidence intervals for the variance, we're going to take our degrees of freedom, n minus 1, times the s squared. Now recall, s represents sample standard deviation. So we want the variance. When we square it, that's the variance. And then divide by that chi-squared value that you got in your table. Then do the same thing, only this time you're going to divide by the left. It seems counterintuitive that you would have the right one on this side of the formula and the left on the opposite, but just keep that in mind. Now the formula for the confidence interval for standard deviation then would be the square root of those answers. The rounding rule for these intervals, if you're using raw data, round off to one more decimal place than the number of decimals in the original data. For example, if you're working with whole numbers in your raw data, then your variance and standard deviation need to be to the nearest tenth. Then the second rounding rule, if they give you the population variance or the standard deviation, then you need to use that value of rounding. let's calculate a 90% confidence interval for a sample of 24 watches, knowing that these have a sample standard deviation of 4.8 months. The steps for this process involve the following. We first need to identify what chi-squared right is. Okay? Now that takes 1 minus your confidence interval to give you 0.10. Then you take that confidence interval and divide by 2. That's 0.05. This is going to be the letter I'm going to look for. This is our alpha. And in the table, we're going to look that up. Okay? So go to our table. And we're looking for degree of freedom, 24 minus 1, which would be 23. All right. So 23 and then alpha 0.05 and that's, so 23 alpha 0.05. And I'm getting 35.172. Record that. 35.172. Then to find chi-squared left, I take my alpha, which was that 0.10, 1 minus 0.05, and I get 0.95. Notice that with chi-squared right and chi-squared left, you add them together, it equals 1. Okay? Now let's go to the table and look for that 0.95 and our degree of freedom of 23. 23.05, or 0.95, excuse me. We already had the 0.05. 13.091. All right. Now that we have that piece, our two table values, then we can go ahead and find the confidence interval for the variance. All right, so that's our degree of freedom times our sample standard deviation, and square that, divided by chi-squared right. So that's that 35.172. And it's going to be between our, again, 23 times our sample deviation, square it, divided by chi-squared left. Our table value was 13.091. You can type these into the calculator, and we're going to round to the nearest tenth, giving us 15.1 and 40.5. Those are the confidence intervals for the variance. To get the confidence interval for the standard deviation, we'll just take the square root of those variance values. And then I'm going to do the square root of 40 and 5/10. Rounding to the nearest tenth gives me an answer of 3 and 9/10 and 6 and 4/10. So we can be 90% confident that the true standard deviation is between 3 and 9/10 months and 6 and 4/10 months. This next example comes from page 404, number 5, talking about carbohydrates in yogurt. You'll notice with this particular problem, it gives you various data of all different types of yogurt and all the carbohydrates in there. What we're going to do is enter in those values into our calculator. So please pause the video as you enter the values into the video, and then we'll continue. Now that the data is into the calculator, go to Stat, Calculate, 1 var stats. Coming from list 1, go down to Calculate, enter. I want to make a note of the sample standard deviation and how many were in my sample, which was 17. 10.1 and 17. Now, go and let's calculate out chi-squared right. And that's by taking 1 minus our confidence interval of 0.05 and taking that answer and dividing by 2, 0.025. Once that has been identified, then I can go to the table and get an answer. Table G. Notice I'm on table G, chi-squared distribution. My degree of freedom is 16, and I'm looking for 0.2025. So 28.845. 28.845. Then I've got to do a similar idea for the left. This time taking 1 minus 0.025 to get 0.975. Return to the table. Degree of freedom 16. 0.6908. .908. Okay. Getting that calculated variance. We're going to take 16, our degrees of freedom, times our sample standard deviation, 10.1, square that, divided by our right value, 28.845, and that's going to be our less than, and then the upper is going to be divided by our left, 6.908. Dividing those out, noticing I'm going to round to the nearest tenth, 56 and 6/10, and 236 and 3/10. Now I still have to figure out the standard deviation. Remembering standard deviation is then just the square root of these two values. Now I do the square root, getting 7.5 and 15.4. I can be 95% confident that my standard deviation will fall between 7 and 5/10 and 15 and 4/10. This concludes section 7.4. I would highly recommend you looking through the PowerPoint because there were quite a few examples that I just didn't go through. They're all worked out for you. Also, if you have any other questions, please let me know. Thanks.